Welcome everyone to our MSCC AI webinar series. Today's topic is AI in the classroom with Jetstream2. I'm Jessica Johnson. I'm an MSCC Cyber Infrastructure Facilitator, and we're so glad that you all could be a part of today's session. Before we dive in, we just want to add some few notes. If you weren't able to attend our recent MSCC technical webinar, which was on getting started with Jetstream 2, please do not worry. The full recording of that introductory session is actually available right now on our MSCC resource website, and we'll actually drop the link to that session in the chat so that you can bookmark it for later for your reference. So before we actually get started with our speaker, I also wanted to share a few quick housekeeping notes for today. First, this session is being recorded and the link to the replay will be emailed to all of you as well as anyone else who's registered and wasn't able to make it today. If you'd want to speak or ask a question out loud, just use the raise hand button and we will unmute you and bring you onto camera if you'd like. If you have a question, please use the Q&A box for any type questions, and our speaker will be pausing throughout the presentation today to answer questions during designated breaks and at the very end. And lastly, we just want to share that access to the allocation that will be used today is temporary, and the duration of access will be specified by our speaker. So with that, just want to introduce our wonderful speaker. Danny Havert is a research computing specialist and data analyst for Jetstream2. Having spent the last 3 years helping users integrate cloud-based research computing into their research and curricula, he is passionate about reducing technical barriers for educators and students alike. Prior to the work in cyber infrastructure, Danny earned a PhD in physics, studying critically in the cortex, giving him a firsthand understanding of the computational hurdles researchers and students face. So with that, I will pass it over to Danny, and we'll get started with our session today. Thank you all.
Thanks, Jessica. Let me start by... Oh, Jessica, can you give me permissions to share? Perfect. Thank you so much. Okay. All right, so hi, everyone. As Jessica introduced me, my name is Danny Havert. I work at Indiana University on the Jetstream2 project. I'll talk about what Jetstream2 is, and we're going to talk a lot about AI today. Just a very brief intro, if you haven't heard of Jetstream2, we are a nationally funded, NSF-funded cloud research computing provider that's open to any researcher, educator, staff at any nonprofit university or college or educational institute, what have you. So yeah, we want to just sort of democratize this access to computing resources, and that's what we're here to talk about today. A little bit of housekeeping. So go ahead and if you want to scan this link or copy the link down here, this go.iu.edu link, I recommend to do that. That'll give you access to a PDF copy of the slides in your browser, so you can follow along, save it for later, and so on and so on. Feel free to scan the QR code on your phone as well. I will give you just a couple minutes to do that. And let me actually copy this and paste it in the chat here as well. So now we can have it. Great. All right. So first thing I want to do is sort of poll the audience. When you hear AI, what do you think of? This is a new link here. Let me go ahead and copy this again into the chat. And this will open up a Slido link. And feel free to just put whatever comes to mind when you hear of AI. Feel free to input as many times as you want. You can, it'll ask, input your response. Do you want to add another response? Do you want to add another response? And you can input those responses. And if you do that, and you think of more, you can hit add response and add even more responses. So go ahead and do that. I'm going to as well click this link. And I will proceed. And it just asks, when you hear AI, what do you think of? So my response, I don't want to influence anyone. I've thought about this a lot. I just do this to pull this up. So yeah, please go to that link. We've shared it in the Zoom chat as well. It's the second link there. The first link is just going to the slides. And just tell us what you think of when you hear of AI. Seeing automation, that's good. That's a big one. Non-deterministic, machine learning, ChatGPT, yes. Agents, I like that. Curiosity, ooh, LLMs, Claude. Hyped up technology. This is good. Chatbots, prompts, fake information, assistant, helpful tools, need for change in education. These are all really, really good. Okay, I'll come back to this in a little bit, see how this has maybe changed. For now, let's keep going. So, welcome to AI in the Classroom with Jetstream2. Who is this webinar for? I looked through the list of attendees, and we have a lot of faculty, staff, educators at institutions. So if you just want to maybe have a better understanding of what AI means today, if you want to be responsible with how to use AI in your class, if you're interested in sort of large language models, RAG, classroom-ready AI workflows, and if you're also just curious about how to actually do these and use, using Jetstream2 or other national infrastructure, because as you might know, to do AI, you need either money or hardware to run it on. So we're going to talk about first, sort of what is all this AI stuff and what does AI even mean? Then we're going to get into some more practical things. I have the 4 AI pathways for the classroom. We're going to talk about terminology, the different tools that are available to you, and what are some limitations. And then we're going to touch on Jetstream2 specifically in the context of AI. What are some features and use cases? Then we'll get to the interactive demo. If you provided your access ID to us before or during the registration process, we've already added you to our training allocation, and we'll help you get launched into that and running our demo with us. And then finally, if time allows, I can briefly talk about getting an allocation. I know this was talked about in the previous Getting Started on Jetstream2 workshop, so we probably won't get to it, but I just wanted to have those slides there just in case people were missed that. So what is all this AI stuff? Artificial intelligence, this is just a broad definition. It's the capability of a computational system to perform tasks typically associated with human intelligence. And it has a long history. AI has definitely become more of a buzzword in the last half decade, but there's a long history of AI before that. In computer vision, machine learning, deep learning, and those sort of like, I'm going to call them old school AI definitions. Those are sort of just under the umbrella of artificial intelligence. Artificial intelligence is very much an overloaded term. And that is the next slide. It's an umbrella term. There are many, many, many subcategories under AI. So some of the things that I saw, we saw like large language models. Those are the language model section. There's deep learning and machine learning, which are related. Computer vision is a big one that's been around for a few decades now. Generative AI is what people might mean by AI today. And then there's even robotics, sort of physical, training of actual machines to do tasks. And then some other things that I didn't even list on the outside, but you can see here in the middle, like vision and speech and so on and so on. Like I mentioned, AI, the sort of term AI has changed over the years. AI, a decade ago, had a much different meaning, and it wasn't as sort of mainstream as it is today. AI largely meant machine learning and computer vision, but also sort of in the business world and legal world, there's these expert systems, there's intelligent tutoring systems, and natural language processing has been around for a long time. It's just in recent years that it's really exploded with large language models and chatbots. But these things have been around for decades. Um, uh, but today, the sort of meaning of AI, I think, has changed. And it really came about with chatbots, this prompt-driven approach where a user asks something or describes something or uploads something, and the large language model, the chatbot, it runs on some GPU hardware somewhere, and it computes and it computes and it computes, and then it spits out a response back to you. It's just sort of this workflow of like ask, compute, and receive. So now when people say AI, they really mean like chatbots, coding assistants, image and video tools, image generation, video generation, workflow co-pilots, and the new one, which is agentic AI, and we're going to be showing that off in the interactive demo later on. So yeah, basically today AI means large language models. So let's talk about large language models. A large language model has a life cycle, and the first part is, well, it has to be trained. And I'm not going to get into sort of the details of the training. It's complicated with sort of the neural networks and everything. We're not going to talk about that. But what we should know is how expensive it is to train one of these models from scratch, this foundational model training. I mean, you need thousands of, well, millions of GPU hours to train these foundational models like ChatGPT, Claude, and so on and so on. These AI companies, I mean, they are spending millions and billions of dollars to train these foundational models. And the reason I bring that up is because I oftentimes hear from like researchers saying like, I want to train a model. And when you just say, I want to train a model, well, do you want to train a model from scratch? Because if so, you're just not going to be able to. Unless you are a billionaire already, you're not going to be able to train a model from scratch. So what you're going to be doing is probably using one of these pre-built models, these foundational models, and then doing fine-tuning on top of that. That's what a lot of people mean when they say training a model. They don't mean building a model from scratch. They mean taking an existing model, adjusting its weights, somehow adding a few extra layers to the model that already exists. And we call that fine-tuning. So I have this under the second category, adapt the model. And you see this a lot in like medical fields, legal fields, in coding, where they've taken the foundation model and they say, okay, let's retrain, well, not retrain it, but additionally train it with extra sort of information baked into that model. Once you have that, now you can actually use the model, and we call this inference. So this is where you run the model, and this is where the chatbot comes in. So now you have a model, you've maybe fine-tuned it for a specific purpose, and it's out there, and people can run it. And it runs on some GPU hardware somewhere, and it generates output bases off the input, and it gives it back to you. So, right, asking a chatbot to summarize a document, and it's an example of inference, and all sorts of other. This is like 95% of what people mean by when they say I'm doing AI or I'm using AI is I'm using inference. I'm using a pre-built model. And then once you're using the model, you can add outside context. And this is what we call retrieval augmented generation, or RAG. This is a common workflow where it's essentially just running the model, but you have a sort of extra database, let's say, that the model has access to, and it can go and retrieve data from that database based off of the context, and then inject that context into your sort of context window to use when it's computing the output. Yeah, and this has become very popular. You might have A lot of companies are assigning all their like documentation or whatnot, files, and they're giving this to a database and giving it access to the model so that it has all that extra context. How did we get here? This chart is only it's only about a year and a half old, but it's extremely out of date because AI has the rate of change of AI has changed a lot. I'll talk about or briefly mention BERT. Give BERT a call out in 2018. This was sort of like a transformational model, and then we have GPT-01 also in 2018. And then in the last 5, 6, 7 years, it has really exploded. I'll make a couple call outs, GPT-2 and 3 and Claude. We have Llama here, GPT-4, Quen, you might have heard of Gemini, and DeepSeek R1. This is a paper from 2025. There would be like 20, 30 more entries in here just in the last year, a year and a half, probably more than that. It's hard to keep track of. The point of this slide is really the landscape of models and large language models is changing so rapidly. These new foundational models are getting released all the time, and it is impossible to stay up to date with everything. That would be a full-time job in and of itself. And here you are being asked to do all this others, you have your real full-time jobs, and now you have to learn AI on top of that. So that's what these workshops are for, sort of catch you up. And we'll do that. I'll start with some sort of essential LLM vocabulary. I'm just going to go through these briefly because I'm going to be using a lot of these words. In fact, I've already used some of these words already. So prompt is what you give the model. This is the user input or your instructions. The context window itself is how much information the model can consider at once. So this is maybe if you're in a chatbot, all of your previous chats will be saved in that context. And the context window is how big that can possibly get. And some of these models are even adapting so that when your chat gets long enough, it is actually summarizing previous chat and then using that in your context as well. Because if your context gets larger than what the model can handle, it has to do some fancy stuff. But context and context window are important terminology. This is just what is being stored in the context that the model has to, run your input and create an output. A token is just a unit of text that's processed by the model. It is not a one-to-one for a token to a letter or a word. It's more complicated than that. But tokens are important because if you ever go to commercial options, they charge you by tokens. And even non-commercial options might have a limit on the amount of tokens you might be able to use in a given day, for example. So token is really just it's almost like their currency that they compute in. Model weights, these are the learned parameters of the model. Underneath the hood, it's really just a fancy neural network, and the weights are just, the weights are from everything that's been trained on the model, and it's where the magic happens, really. Fine tuning we talked about already. RAG we talked about already. Hallucination, I'm just putting this here because I think we all know at this point, but large language models, they do hallucinate. They will make information up and it sounds very plausible, but it's totally just fake and false. And you have to be careful about that, and your students have to be careful about that. And I think that's why it's really important to have them use AI so that the more that they use it, the more familiar they become with, recognizing these hallucinations and recognizing when they need to challenge it or search for outside context. Multimodal, this just is a model that can work with multiple modes. So text is like one mode. So this is sort of where GPT might have started, where you just input text and it outputs text. But nowadays, if you go to ChatGPT and you're using their most recent model, you can input text, it can output text, you can input images, you can input audio, videos, files, PDFs, so on, CSV files, so on and so on. And it can even output all of those as as well. So these newer models are multimodal. And then finally, agent. An agent is a system that can plan and call tools and act. We're going to talk about agents more later. So I promise we're going to be talking about, we're just going to focus in on 4 sort of pathways for how you might use AI in your classroom, depending on what your needs are. The first one is inference service. And I think I mentioned this is like 95% of people that use AI are just talking about inference. So this is you using a hosted model through some sort of chatbot interface, through the API, through Notebook, or some sort of agentic or copilot interface. Second, I'm going to briefly, I'll spend most of the time on inference service and using an inference service. I'll briefly mention deploying a model because I know some of you might be interested in this and some of the tools. This is, say you want, right? Maybe you want to do some fine tuning, which is step 4, but in order to do that, you need to actually deploy a model yourself. Also, maybe you want to provide a service. Maybe you're teaching your students like how to actually run a model from scratch, or not from scratch, but just to run a model so that they can, customize or learn something. Anyway, there are use cases for this. I'll talk about that later. Third is RAG. I'll briefly mention like tools for this. There's a lot nowadays. The RAG is sort of like built into a lot of things. For example, like Notebook LM has sort of built-in RAG implementations, and even other chatbots have this as well. And then fine-tuning. Again, we've talked about this. I'll briefly mention it. I'm going to spend most of my time on inference service. So, in inference service, I've mentioned this already. I'll mention it again. You send a prompt. The service runs the model using the weights and the GPU and everything, and then it outputs a response. And that's all done through tokens, right? You send a prompt, so there's input tokens, it runs its analysis, and then there's output tokens. And there's a lot of different ways to interface with these large language models with an inference service. The most common being the chatbot or web interface. So if you go to chatgpt.com, that's what you're interacting with there, or Gemini, or Claude has an interface as well. That's really, really extremely useful. I think at this point, it's probably safe to say everyone has at least used a chatbot before. You've maybe logged into ChatGPT to see what all the fuss is about, or maybe you're a really heavy user of these things. But yeah, I'm hoping we're sort of familiar with that, and I want to spend more time in like, okay, let's move beyond the chatbot, right? We know about chatbots and we know about prompting and everything. Let's move beyond that. What's next? Next is API, and this is where you start really getting the power of these large language models. An API is, well, it's a programmable endpoint. So you can now talk to the inference service, not by manually typing and receiving the output. You can actually set up a program, maybe it's Python or in Jupyter or R or something, and you can talk to that endpoint. You can talk to the large language model within your program. This unlocks a lot of extra capabilities. And the big one are these embedded copilots and agentic harnesses. So embedded copilots, you see these in like Salesforce has them embedded in their software. Atlassian has them. Microsoft Copilot, of course, is a big name. And these copilots are just sort of like, it's maybe built into a web interface or built into your software, and it knows specifically how to interact with that software to do certain things. And it's sort of like the building blocks on an agentic harness. Agentic harness is now, okay, what if I have a very generalized agent on my computer that can not just talk to the LLM, send input and receive output, but it can also run things on my computer, right? It can actually execute functions on my computer. It can open programs on my computer. It can change my file system. It can create files, delete files, right? Of course, that's, scary. We'll talk about that a bit later. But this is really, really, really powerful because now you're not just, okay, typing in my input, copy pasting my response back to my thing. it is now just fully automated, and it's doing everything for you. Okay, and of course, there's a bunch of different types of models. I have a few listed here. The closed commercial models, like Anthropic, OpenAI, and Google. These models, you're going to have to pay a service or, through a license or somehow in order to be able to use. Open weight models are models which have, well, their weights are completely open. So you can download this model and run it on your own hardware. Or in the case of Jetstream2, run it on Jetstream2 hardware, because of course you need big, expensive GPUs to run these. So some examples here are DeepSeek, GLM, Kimi, Quen, and there's a lot of open weights models. Open source, I just have listed here for fun. We say open source rather than open weights. These are models that have actually, the whole training process is actually open. Open weights models don't tell you how they were trained. They just tell you, here's the weights. You can use them on your own hardware to run this. Open source is actually, hey, this is step-by-step how we trained it, and you could train your own. And there's really very few of those. I just have one example there. So the chatbot interface, this is probably what you're used to, ChatGPT, Gemini, so on and so on. I'll just briefly go over this. It's useful for brainstorming. It's useful for explaining things, summarizing your readings. You can upload a PDF file, have it summarize it. You can use it as a tutor if you prompt it correctly. You can have it ask you questions and go back and forth, and sort of like role-playing these scenarios, and so on. And there's a lot of use cases for this. I think this has been studied a lot, and I hope if you have not interacted with one of these chatbots before, I highly recommend doing it. They're extremely powerful. Just test it out for whatever use case you have, and put yourself in your students' shoes also, right? Have them, don't just look at it from a lens of like, okay, how are they going to use this to cheat? But like, how can I use this to help them learn better? Because I think it can do that. And then I have this note here about AI literacy. And it's review the output, revise your prompt, verify the output, and disclose that you're using it. I think this is really important for the classroom. Your students, they need to learn how to use AI to learn both its usefulness, but also its limitations. If they just never touch it and they're straight away from it, then they're not going to learn what it's good at and what it's bad at and when it can hallucinate. So I think it's just a skill that they need to learn, and you need to be sort of the one to guide them through this. You need to teach them, don't just send a prompt, accept the output the very first time, and call it done, right? Review that output, revise your prompt, verify, tell it to cite sources, verify those sources, click on the links, and then disclose that you've used it. Maybe have your students upload the entire chat history so you can really see like, how are they using this, and then use that to guide them towards a better way to function. A couple other options here I have for no cost options. Of course, in the world of AI right now, it's a very lucrative world, and it's hard to find free options. It's also very expensive to create these models, so it's going to cost money, and it's expensive to run the models. But that being said, in the Axis ecosystem, Jetstream2 is part of the Axis ecosystem. There's two specific options I think of off the bat. One is Jetstream2 does have an inference service, and this is available to anybody with an Axis ID. I linked to the documentation page there, but this will also have a link to the inference service. There's a chatbot interface, and then we also have on our docs how to get access to the API. You will need to actually have a Jetstream2 allocation to use the API portion of it. But even if you don't have an allocation, you can use the chatbot sort of interface as well. And we run open weights models. Of course, we don't have ChatGPT or Gemini or something. We run open weights models, and we run that on our own hardware. Anvil GPT is another one. This is from the Anvil supercomputer at Purdue. I linked to their documentation page. They just, you do have to request access, and I believe they want you to have an active access allocation, on Anvil in order to use this, but I would reach out to them and ask, how you can get access to this and make your case for this. And then I have Kaggle here. Kaggle's just a fun one. You can use it to sort of test different models and run them and try different things. And it's free up to a point. So just another recommendation I wanted to throw out there. Okay, let me pause. I'm seeing some questions. So I have, how can I tell I'm working with an agent versus a simpler large language model? I've seen what I thought was an LLM, perform some degree of planning, etc. Thanks. Yeah, so when you go to a chatbot, they now have like the thinking models where they will sort of plan out a response and whatnot. But in my mind, an agent, and I'll talk about this more later, I have a slide on agents, but an agent can really like it's not just interacting with their system. So like if you go to Gemini or GPT, it can interact with their tools, and in the background they have tools like they can create PowerPoint presentations. They can do all this in the background. What I think of though, it's the difference is letting it run on your end, right? So now you can run an agent and it can actually do things on your system. That's really what I'm thinking of when I say agent. And now it can install things on your systems. It can do things like that. So does that make sense? Like chatbots, it can do a lot and it's doing agentic looking things, but it's all in the background and there's no like back and forth between your system and the large language model. And then second question, can you comment on managing the following: risk of exfiltration, restricted data, and reproducibility in AI large language model agent-based research? Yeah. Yes, don't use a commercial model if you have restricted data. Just you don't. If you have restricted data, I would get access to well, it depends also on the restricted data. If it is if it's like HIPAA or FERPA data, that is extra locked down, and you can't typically do that on national infrastructure. You would need to do that locally at your own institute in some sort of environment that's very locked down. So that's if you have like HIPAA or FERPA. If you just have restricted data, but it's not right, your university might have guidelines on the different sort of categories and where these can and can't be run. But there are certain categories of restricted data, maybe not like highly critical, but just sort of semi-restricted that can be run on national infrastructure to identify data, so on and so on. And if you have that sort of data, you can run it on national cyber infrastructure. And in that case, you can either use, like, for example, our Jetstream2 inference service is one. This data is not exfiltrated. It is running on our system, and we never let it leave our network. Or you can run it yourself on hardware that we can provide. So if you can get a GPU instance on our system, you can run or deploy your own model or fine tune it or do whatever have you, and you can run it there on that model. Yes, I hope that's answered your question. Oh yeah, and I have a question. Zed is on the list of harnesses. Does it do that too? I thought it would use, yeah, it would use ACP to control Pi OpenCode, but not be a harness. That's a good point. Yeah, I guess that sort of points to how these terms have not been fully defined yet. They call it the Zed. They have. I'm trying to think. I do use Zed, but they call it like Zed AI or Zed agent or something. And it does agentic things. But yeah, I guess I don't know fully enough about the under the hood of Zed to answer the nitty gritty there. But yeah, good questions. Thanks, and keep them coming. Okay. When you're doing interacting with a chatbot, you need to learn how to prompt. And this is why I say we need to get our students using this, and we need to guide them through this because we need to teach them how to correctly write a prompt. And I have just some sort of a useful prompt. You need to include a role. So this is like acting as, well, I have an example here, acting as a first year biology tutor, or acting as a professional in cyber infrastructure, or so on and so on, right? So start with a role, you have to give it a task, and you have to give it the context of the task. The more context you give, typically the better this is going to be. So like, say what the audience is going to be. That's the second to last bullet point, but this is included into context. Say like, why are you doing this, right? What is the goal? What is the purpose? What are the constraints? What format should the AI output in? Do you want it in a CSV? Do you just want it in like Markdown? Do you just want it a text? Do you want it to actually create a PowerPoint file? Do you want it to create an image or a graphic or so on and so on? So yeah, there's an example here. This is just a basic example. Act as a first-year biology tutor, explain cellular respiration using an analogy, then give 3 check for understanding questions. And you can use this as a tutor, right? It can actually create questions for you, and you can go back and forth. And it's not just, okay, hey, that answer that you gave to my question was wrong. You can ask it, okay, explain that process, right? And this is where I really think that, guiding students and teaching them how to do this rather than just, hey, let me use this to cheat on my homework, right? Let me just ask the question to the AI. The chatbot tells me the answer. I copy paste that into my homework and I call it quits, done, right? Let's move beyond that. Let's teach them how to use this properly as like a learning tool. It's really just a better, it is so powerful if you want to learn something new. So yeah. Okay, and as promised, I really want to move beyond chatbot. Chatbots have been explained to death, and there's all sorts of guides online. I recommend you looking up for how to prompt a chatbot if you're unfamiliar with that. But I want to move on to API. So moving from back and forth, one at a time, sort of, or one back and forth with a chatbot to let's actually interact with under the hood with the API. And you can use this now for batch document analysis. I worked with a professor who was teaching a business class, and she was teaching her students how to use the API that we host on Jetstream2 with Jupyter Lab so that they could basically remember this is a business class, so they would have a huge list of like reviews for their business. And they wanted to do some sort of sentiment analysis, but also like summary of these hundreds and hundreds of reviews. Something that would normally take you a very long time to read through each and all these reviews. But now you can send to an AI through an API, and it's not a manual process of uploading one file at a time. You can do this programmatically. And those students would submit all those reviews, they would change their prompt, and they would get back a response, and it could actually output like a CSV, it could generate graphs, and so on and so on. That summarizes sort of those reviews. So it's just one example of how you can use an API to really like train these students. And that's just in one context of a business class. And there's all sorts of other ways you can use this. You can use this if you are teaching computer science. You can use this to sort of build, if maybe teaching a web class and you want to sort of like build on top of that web framework a chatbot within your interface. Well, in order to do that, you're going to have to talk with using the API to an actual large language model under the hood, so on and so on. There's all sorts of things that you can use the API for. And the big one, I think, is agentic AI. And so once again, an AI chatbot, you input, it runs, it computes, and it outputs. An agentic AI has a loop, and an agentic AI can do a lot more. It can spawn off multiple subprocesses. It can work through multiple steps. So you can give it an end goal, and it can work for, I've messed with these things. I've had one where I gave it a complicated prompt, but I told it to basically like on a virtual machine, told it to create like a web service that did, this complicated thing. I think it ran for 2 hours and it created it. But part of that was I told it, hey, along the way, test this, right? So don't just create it, but test it. And if you find any errors, right, then go back and fix those errors, test again. And so the reason it took so long, right, it created the first draft, but now it ran it, it tested it, there was some sort of error that spit back, it read that error, and then it modified the code and tried again. So this is where that agentic AI is really powerful because it can create a loop and it can just keep going until it finally reaches that end goal. And it can do very, very complicated things because it's just constantly on this loop. And also with agentic AI, you can add extra tools. So tools would be sort of like how different things that it can interact with. Maybe you want it to hook up to like an MCP server or something as an example where it can like interact with your Salesforce, authentication service or your Google Slides or something like that. And then there's skills as well. Skills are sort of like built-in it's almost like a RAG, but it's like extra context that it can inject in. So if it recognizes that it's doing a specific type of action, like for example, let me debug the error log, right? That's maybe a skill that you can add to your agent so that it specifically knows when I'm doing this task of debugging, I have this extra context that's always going to be added to my context window to help it along and not sort of fall apart more often. So agentic AI is really, really powerful. We'll explore this a little bit with something called open code in the demo. Okay, we talked a lot about the chatbot interface. I want to talk about the other three: deploying a model, RAG, and fine-tuning. And I just have 1 or 2 slides for each of these. I'm just going to sort of talk about why you might want to do it and what are some tools that are available. That's not really going to be the focus of this because I know 95% just want to do inference. But I do want to have this here because if you are one of those 5% of people that are interested in actually deploying your own model or teaching your students how to deploy your own model, Jetstream2 is a great spot to do that because we have the hardware in order to do this. So, deploying a model for inference. This is when you really need a customized option. Keep in mind that if you're deploying a model, this means you are managing the model itself, the files for the model. You need to have the hardware, which, like I said, you can get through Jetstream2 or other national cyber infrastructure available to you. You need to manage the inference software. So if you're going to be deploying this model, well, presumably you're going to be deploying it for people to use. And so you need sort of a way for those people to interact with that. And that can be the chatbot interface or the API. So you need to be able to handle that. And then, of course, who gets access to this? Who are the users? How do they have access to this? How do you, authenticate to this maybe service that you're providing or somehow? So just keep in mind, this is not like for the faint of heart. Don't just go into it and be like, I need to deploy my own model. If you can get by with using a model that already exists out there, do that because this is a lot more work. I have listed here some commercial and sort of open source or free tools. Llama.cpp is sort of the old school way. It's very much if you just need to run a model. And then there's other things via LLM and OLLAMA and so on and so on. Check those out if you're interested in this. I'm not going to get into that in this session. It's only an hour and a half, and that's not the focus. And then if you're actually searching for models, Hugging Face is sort of like the go-to place. So you can go huggingface.co/models, and you can search. And this is also where you can download open weights models as well. My one thing to consider here is if you do go down this path, you're going to need GPU, and you're going to need, well, I say need GPU. It is possible to do this on CPU, but it's much slower. So really, for any practical purpose, you're going to need GPU. And you're going to need VRAM, video RAM, because the entire model and all of the context that your users might provide, so that context window, they have to be able to fit on that GPU memory, the video RAM. So keep that in mind when you're browsing Hugging Face. When you're browsing Hugging Face, it actually has sort of the size of each of the models as you're going through, and it's literally just the size of the files, because those files are the weights. And so that, at bare minimum, needs to fit onto your video RAM. So if you have a GPU with 40 gigabytes of video RAM, you're not going to be able to put a model that's 50 gigabytes in size on that. It just won't work. In fact, you're probably not going to be able to do 38 or 36 or whatever. You're going to also need to have extra room for that context window, depending on how big you want to make that context window or how big the model can support. There's all sorts of guides out there. If you want to learn more about this, ask an AI, ask a chatbot. That's going to be my recommendation, because these things are really good. Tell it specifically, give it that context that you want, tell it what you want to do, help it guide you through that. Or of course, find a guide online. My one last bit I'll say is use a quantized model to fit it onto to fit it on something. It is almost always better. So, okay, brief. What is a quantized model? So typically when models are created, they're in like 16-bit or 16-byte, I can't remember, floating point. You can reduce that size by half by going down to 8, or half again by going down to 4. And this just means that the weights themselves aren't as precise in values. And the content, whatever. Not getting into the nitty-gritty, promise. Quantized models perform pretty well. They're not going to be as good as the full model, but they're pretty good. And it's almost always better to do a bigger model but quantized than a worse model but not doing quantized, right? The quantized version is not as big of a jump down in quality as you might think. So I pretty much always recommend using, I would say, try for an 8-bit or 8-byte model, quantized model, and if that doesn't work, go to 4. I would leave 4 for not, like 4 is great for teaching. I wouldn't use 4 for like a production. And if you go to Hugging Face, a lot of these models, they tell you if it's quantized or not. But I just wanted to get that out there. I have a question. For sessions such as that 2-hour compute time, did you or can you ask the agent to persuade progress such as priority score? Yeah, actually, I was using OpenCode for that, which we'll talk about later. And it actually had a progress bar that it just automatically created. And it basically, the way it did that is like a checklist, and it said like, hey, these are all the tasks I need to do. And anytime it finished one of those tasks, it would check it off and check it off and so on. So that sort of functionality was already built in. Good question. Third pathway is RAG. I'm gonna look at the time, 2:50. Okay, I'm gonna spin through a couple of these. There's a lot of options out there for RAG. You might use it for like syllabus Q&A. As a reminder, RAG is just adding extra context. You give it extra sort of database of documents that the model has access to pull in to the context window for extra context. So yeah, this can actually be useful for you. You can add sort of your course syllabi or something to this context. Keep in mind your university's, if you're going to use a commercial model here, you might want to check with your university before you upload a syllabus to one of these commercial models, because not every university is going to be okay with that. So yes, always check that. And I advise, don't do it unless you know you have permission to. But there are other options out there as well for you. So yeah, just adding extra context. That's the general use cases here, and some sort of common RAG and document AI tools. You can go through these. You should have the slides, so look through these on your own time if you're interested. I'll just do a call out to Notebook LM because that's a pretty popular one for sort of building your own sort of library of documents. Great. Finally, fine-tuning. Fine-tuning, you really only want to get into if it's specifically what you're trying to teach your students, or if nothing else that we've talked about works. This is sort of a last approach. This is definitely high complexity. It's used a lot in the research world because they might need to fine-tune a model for, well, I've seen people fine-tuning models. I've seen projects for like maybe translation to a language that the commercial models just don't know, or fine-tuning it to be much more knowledgeable in their specific research, so on and so on. If you can't do that with just RAG, right? RAG is going to be easier to implement than fine-tuning. So this is really for like more advanced use cases here. Yes, fine-tuning versus prompt tuning. Prompt tuning, always go with prompt tuning. By prompt tuning, we just mean like adjusting your prompt, or adding extra context with the RAG or something. Always try that first before going fine-tuning. You're going to go into a rabbit hole if you get into fine-tuning. Not to say that this isn't, a valid use case, but for 99%, it's not going to be. And then finally, I just have this sort of complexity. Like if you need to do more than just interact with an inference service, if you need to like deploy your own thing, if you need actual hardware, this is sort of like the complexity. So at the bottom, I would put deploying a quantized model, so quantized inference. And then we have the full inference that's going to need more VRAM, more GPU, but it's also going to be more powerful. RAG I have up here, but RAG can sort of be built on top of quantized inference or full inference. It's just extra context, which means you're going to need extra VRAM or more powerful GPUs because of that extra context. And then we have the fine tuning, that's 4 and 5. And then 6 is something none of you are going to be doing, which is foundational model training from scratch. This is the thing that takes billions of dollars to do, and thousands, hundreds and thousands and millions of hours of GPU hours. You're not going to be able to do that on national cyber infrastructure. You need your own data center to do that. So I have it here. If you do end up going beyond just needing to do inference and you need to deploy something, I would stick to try quantized inference before full inference, and then you can do RAG on top of either of those two. Those are definitely possible on smaller GPUs that we have like much more widely available on Jetstream2. If you need to do fine tuning, you can still do that. You just need a more powerful GPU to actually, because you're basically doing training there, and that requires a lot more powerful GPU. All right, 254. I'll hop through a little bit. Why should you even use Jetstream2? What can we do for you? What are some use cases? I've talked about Jetstream2. We are a nationally funded cloud research computing service or provider that's available through the Access program, also through NAIR Pilot being the National AI Research Resource. We're a very big system. Specifically, I'll highlight the GPU. We have 90 nodes of 40 gigabyte A100s. There are 4 of those GPUs per node, so that's 360 A100 GPUs. We have 8 nodes or 38 times 4, I can do math, 32 L40S GPUs. Those have 48 gigabytes of VRAM, and we have 24 nodes or 96 H100 GPUs, and these have 80 gigabytes of VRAM. If you're just doing a classroom workshop, and even if you're deploying a model or you need to do some sort of AI, even traditional AI like machine learning or something, we have partial GPUs as well. So you can use like half of an A100 or even a quarter of an A100. So those would have 20 gigabytes or 10 gigabytes of VRAM, which is still more than enough to do like, deploying a 4-byte quantized model, a smaller model like 7 billion parameter model. It should be more than enough even to do that, which is great for teaching, right? The purpose is not, doing a production ready thing. It's just to teach them how to do it. So we have those options available to you. If you're a researcher here, you can launch a full A100, or you can get access to H100s as well if you really need to do heavy computing or training. What's unique about Jetstream2, our resources are on demand with no runtime limits. You launch a virtual machine, as it's called, or we call them instances. That's extremely useful for a class. You can either, as you'll see later today, with what I've done, you can launch these instances for your students, or you can have your students launch them themselves if you give them access to your allocation. And we have a fully interactive computing environment, right? There's no queues like you might be used to with other high performance computing systems. You have a dedicated, hardware that you have access to that you're not sharing with anyone else. And all of our instances come with a graphical desktop if you ask it to, and so on. So this is great for people who aren't familiar with command line. You also have full admin access. You can install whatever you want. And yeah, it's available at no cost because we're nationally funded from the NSF. Of course, what are some use cases? If you're teaching like computer science, you can have a reproducible development environment. You can create identical environments. I have a question. Are all the Jetstream2 GPUs using NVLink? So we don't. We do. I'll admit I don't know what NVLink is, but I'm gonna take a guess. We do PCI pass-through for our full card GPUs, and we do a vGPU, which is similar to time slicing for our partial GPUs. If that didn't answer your question, let me know because I'm not 100% sure what NVLink is, and I just took a guess. Okay, moving on. Machine learning and AI, of course, we have GPUs. You can use this hardware to talk about to run AI workflows on here. Visual data analysis, we have desktops. And finally, Jupyter Hubs and web development. I saw a few of you interested in Jupyter Hubs from your registration questionnaire. I'll link to some documentation in a little bit for how to do that. But basically, you can launch and host your own Jupyter Hub on our system, and we have guides for how to do that. It's a little bit more in depth than, for example, like just having your students run their own Jupyter lab on an instance, but there's a lot of use cases for this. And then, of course, you can also do web development, and the reason Jupyter Hubs are possible is because you can have persistent public IPs. Excuse me. I see someone saying, can I share my slide? Do you mean you can't see the slides? Can we see the slides? Just want to double check. Or do you mean the specific Jupyter Hub slide? Am I not sharing my slides?
I can see the slides, your slides.
Okay, perfect. And I think, let me do. I linked this earlier, but I'm going to copy this again. Oh, did you just link it again, Caleb? Yeah, thank you. Oh, Corin, thank you. Perfect. I'm going to sort of skip through this very, very quickly because I want to get to the demo. But I just want to highlight some of this stuff just so you are aware of it if you decide to use Jetstream2. We have something called Manila Shares, which is a network file system service. So you can create a network file system. Why is this useful? This is useful because if you have a multi-user or multi-instance environment, you can attach this Manila Share to multiple instances at once. Why is that useful? Well, say you have a bunch of course materials that you want to provide to all of your students, or you just want sort of a collaborative space that they all have access to. They can each have their own space, their own virtual machine or instance, but you can also have this manila share added to that, which is sort of a communal file system storage space as well. Super useful for teaching the class, which is why I wanted to bring that. Images, another useful thing for teaching the class. In Jetstream2, you're launching instances, they're virtual machines. I'm not going to get into detail about that. But when you launch a virtual machine, normally you just choose from one of our featured images. So this is like Ubuntu 24, Ubuntu 22, Rocky, so on and so on. If you then do a bunch of stuff in that instance, you install a bunch of software, you add a bunch of files, you do so on and so on, you can now snapshot that to create an image. And now you or your students can use that image to launch instances that will have everything already set up for them. So if you don't want to waste time in your class doing all of the setup and teaching your students, how to do all this setup, maybe that's not the point of the class. Maybe it is, and that's great, but maybe that's not the point of the class. You can do that work, snapshot the image, and then create your instances for your students, and they won't have to do all of that setup themselves. It'll have already been done. So super useful to know. We have a software collection. There's documentation here for that, and we've linked to the slides here. So please feel free to look through this documentation. We do have S3 compatible object storage if that's your thing. If you don't know what that is, don't worry about it. And then we have some extra documentation on like Kubernetes and how to launch a web server. Here are some links. I'm not going to get into Jupyter hubs in this tutorial. We would need a lot more time for how to actually do that, but we do have tutorials on our documentation and on external sites for how to do this. The first documentation is just how to do Jupyter Lab, how to launch a Jupyter Lab on your VM. The second one is how to create a simplified Jupyter hub. It's called the littlest Jupyter hub, and that just means this is a single instance Jupyter hub rather than a multi-instance Jupyter hub. It's basically a less complicated environment, but not as big. When is this useful for? This is useful if you have like less than 50 students and they're not doing like super computationally intensive work. Littlest Jupyter hub can work great. I had an instructor, that same instructor I told you earlier, where their students were interacting. They were doing AI work, but they weren't running in AI locally. So they didn't need actual local GPU. They were just interacting with our inference service API. Well, that is pretty lightweight computationally locally because all the hard stuff is external on other hardware. So they could do just a littlest Jupyter hub. So say you have 40 students, right? Each of those students doesn't need more than a single core to run their actual job. It's pretty simple like Python scripts, but they can still do powerful stuff and interact with an AI externally through the API. So there are use cases for this, even if you're doing AI. Last but not least is a managed Jupyter hub. And this is the full Jupyter hub experience. Only do this if you need it. This is for large classes or for classes where every student or every group of students needs their own GPU hardware, right? If each of your students will be deploying an LLM or doing some sort of complicated, old school machine learning or neural networks or, visual, whatever stuff. If your students need their own GPU or if you have a ton of students, then you would want this full Jupyter hub experience. Fair warning, it's a lot more complicated. It's a lot more work on you as the instructor, but it is possible. People have done it on Jetstream2. We had a course with over 500 students where each student needed a GPU and we were able to help them set it up. So it is possible. If that's your use case, start here, come talk to us because it's more complicated. Thank you for answering the questions, by the way. I see somebody has answered. Thank you, Stephen. You've answered Jetstream2 has NVLink within Node up to 4. Oh, NVLink. Oh, I see. This is multi-GPU up to 4 GPUs. However, since it's not a traditional IPC resource, you can't link together multiple nodes. Yes, that's correct. Thank you, Stephen. Yeah, you can get With our approval, you can get multi-node or multi-GPU nodes. Another question, can you point to a how-to for developing, launching a persistent R-Shiny web app on the Jetstream2 interface? I don't know if we have I would say come talk to us at office hours. I'll have a link to that, and it's on our slides. Or send us a ticket. We don't have specific documentation on how to do that. We have documentation on how to do a web server, and there are if you can find any sort of guide for doing something on Linux, on a virtual machine, or not even a virtual machine, on a Linux environment, that should work. But if that doesn't work, or you just have more questions, you can talk to us. Okay, how am I doing on time? 3:06. Okay, let's zoom through some of these. So the one-to-one instances example. This is an example of how you might use Jetstream2 in your class. And this is actually what I'm doing for our interactive demo. What I have done is I have pre-launched a bunch of instances, and I've named them using each of your access IDs if you gave us one. And I've added you to our training allocation. So the reason I'm telling you this is because this might be a similar workflow to what you do as an instructor. You tell your students, create an access account, right? This is a week 1 activity or day 1 activity, and give you their access IDs. You then add those access IDs to your allocation, and now your students can either launch the instances themselves, or you can pre-launch them, and now they have access to them, just depending on how much work you want to do versus how much work you want to offload to your instance. And the pro here is this is a lot easier. It's easier than setting up a Jupyter Hub environment or a multi-VM environment for all of them. You just have a one-to-one. Each student gets their own instance, and it's nice and easy. If this works for you, I would do this. And we'll sort of see how this works in practice in maybe 5 minutes. Jupyter Hubs, I've talked about this. You can have a managed Jupyter Hub. And we had this case where we had 500 plus students where each of them needed a GPU. And we had this auto-scaling Kubernetes cluster. It's really complicated, blah, 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 blah. We can talk about that more if you want to later. We have an inference service. I've talked about this. There's the link there. To the inference service, and we'll be interacting with that as well. Here's some documentation, and I'm going to skip getting an allocation. So let's move on to our demo. So the first thing I want you to do, let me copy this. If you sent us your access ID during the registration process, we have added you to our training allocation. And what I want you to do is I want you to go to that link. This is our Exosphere interface. And when you go to that link, you should be met with this screen here. If you joined us for the Getting Started with Jetstream2, you might already see the training allocation here. If you have another Jetstream2 project, or if you're added to the MSCC training allocation, you might see that here as well. If you don't see our Jetstream2 training allocation, it is TRA 230023. Type that here. If you don't see that project, then I want you to hit Add Allocation and hit Add Access Account. And this will have you log in using your access account. I'm already logged into my access account, so it automatically went through that whole process, but I'll give you some time. You will have to put in your username and password, as well as do a duo prompt to log in. And once you do that, you should see, well, you're going to see way fewer projects than I have here. These are all the projects I belong to, which is a lot, because I do a lot on Jetstream2. But you should see one that is called TRA 230023, Jetstream2 Education and Training. And I've put that code TRA230023 in the chat. And you will select that and hit choose. And now you should see, it should send you back to the home screen, and you should see a card here with the allocation TRA230023. If you don't have an Access account, just follow along with us for now. It's a little too late to get your Access account created and added to the allocation now. So please just follow along and observe. You can take this or watch the recording later. Okay. I'm trying to go slow so that I don't get ahead of too many people. But just as a reminder, you're going to hit add allocation, log into your Access ID, find TRA230023, and add it. And now I'm going to click on this card here. Let me make this big because I realize the screen is not great. Here we go. Okay, I'm going to click on this card here. And this opens up the home page. There's a whole bunch of cards here. We have our instances, our volumes, so on and so on and so on. I'm going to click on this instances card here, and you can see there's a whole bunch of instances on this allocation. So go ahead and click on instances, and you're going to see something different than I am, because by default, there's a filter for instances that you have created. Well, of course, you guys haven't created. So what you're going to do is get rid of that filter. So clear filters here. I'm going to press this, clear filters. And now you should see every instance here. And what we have done is I've pre-made instances using your Access IDs. So go ahead and search your Access ID. I saw some people saying, yeah, if you, so yeah, so unfortunately, we are only able to add it if you gave us your Access ID during the registration process. We added you to the training allocation. And if not, sorry, it takes some time to do that, so it's a little too late to do that now. So just follow along if you can't get access or if you don't have access or authentication. Sorry about that. So yeah, if you're at this process here, go ahead and search for your Access ID. So my Access ID is D. Havert. And click on your instance. So search for your own Access ID here, and then click on the instance. If you don't see one, go ahead and I'll clear the filters again. If you don't see it, go ahead and type in AI Classroom. So if you don't, this is just if you don't see your name there, and just pick one of these instances here. I have a whole bunch of leftovers here. So just sort of pick one at random, and hopefully nobody else is using that one. If they are, we will choose a different one. These are just leftovers in case we miss. So yeah, once again, I'm going to search my Access ID, and I'm going to click here. This is actually a link here that opens the instance details page. So you should be here for now. And this has some details about the instance, the flavor of the instance, the burn rate, so on and so on and so on. And I'm going to scroll down until I see the interactions card here. And I'm going to click on Web Desktop. This will open so go ahead and do that now. This will open up a new tab. And that new tab should connect you to the desktop for this instance. So I'm going to do that. It opens a new tab. It asks if I want to allow the clipboard access. I'm going to say yes, I want to allow clipboard access. And now I'm in my virtual machine, in my instance that's running on our hardware in our data center. But you're just interacting with it in your browser, right, through this screen. Right, so it's a virtual desktop. I'm going to pause here for a second, make sure we're doing okay. If you have questions and get stuck on any process, please let us know. Caleb is around as well. He can help guide you through if you get stuck. I'm going to keep progressing. I don't see any questions so far. So I want to show off two things with you. One is open code and one is Jupyter AI. So the first thing I'm going to do is I'm going to open up a terminal here, and we're going to do a little bit of a command line. Somebody says, can you comment on virtual versus on-mobile performance? In terms of performance actually on the system, no difference. If you're talking about like the actual display performance, this virtual desktop here is not great. It's okay. You can get like 15, 30 frames per second. If you need more than that, there are options to have sort of better desktop environments. You can use a local VNC software, like VNC Turbo is one, to connect. You can actually use that to connect to the instance. It's actually just running a VNC server on the instance. And you can get a much better like frame rate if you do it that way. Good question. Okay, we're here, and we're going to type in two things, and I'll copy paste these into the chat as well. We're going to do module load. Oh, actually, I think we already have this. Modules. Oh yeah, I thought I had. So we're actually just going to type in one thing, which is open code. You should already have this ready. So I'm going to just type in open code. I'm actually going to maximize this terminal. And this is an agentic harness called open code. It's a terminal, whatever. It's a terminal interface, but a fancy terminal interface. I'm blanking on the name. And what you can do, first of all, I'll mention this is already connected. So I have gone in and already adjusted the configuration here. So it preloads the configuration to connect to our inference service. So we're not using like ChatGPT. We're not using, Claude. We're not using Gemini. We are using models running on our hardware in our data center. And we are connected to it through the API. And now what I can do is if I press tab, I can switch between build and plan. These are sort of the two modes of operation for this agentic harness, specific to open code, but other agentic harnesses do this as well. Plan is for planning out what you want to do. And then once you have a plan ready, you switch to build, and then it can actually execute it. The difference is that plan can read things from your system, but it can't modify your system. Whereas build can modify your system. So it can actually go in, it can create files, it can execute files, it can do all that cool, fancy stuff, dangerous stuff, but fancy. So we're going to start with plan. And you can really do anything that you want. I'm going to start with something simple. So I'm going to say, create a script or plan a script that searches the web for latest AI news. I would like to be able to call this script and it display latest news in a user-friendly, terminal-friendly format. You can write whatever you want, or you can copy what I'm saying. But I would say keep it somewhat simple. Don't do like, a 2-hour potential thing. So let's just see what this does. So right now, once again, we're just in the planning phase, but I'm gonna sort of scroll back up and see what it's doing. Okay, so it's decided, I didn't even tell it to use Python. It said, okay, I'm gonna use Python to do this. So I'm gonna create an ai.news.py file, and it can be executed with Python 3 blah 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 AI knows. It found some news sources. So what's it gonna use? It found some Google News, and it's using Reddit, it seems. Fetch and parse the feed. It's using some libraries within Python. Determine what are the latest things. And it says terminal friendly display, so on. So you can see it's planning out a whole bunch of different stuff. Error handling, packaging, and executing. Okay. While this is going, I'm going to see if there's any questions. Oh, it says next step, confirmation preferences. So it's asking you some questions. Language, Python 3 or so do we want to confirm all these preferred desired default number of headlines? Okay, let's see. Python is fine. Let's stick to top 3 headlines. No preference on RSS sources. Colored output seems great. So every once in a while, it'll ask you for some questions or ask for your input so it can plan accordingly. Yeah, here access restricted Jetstream2. People are getting unauthorized errors. Very interesting. So we do have the API is behind a firewall, but it's supposed to be allowed for any instance that is running on Jetstream2. So as long as you're doing this from within this web desktop environment, I'm very confused. That's interesting. Unauthorized error. Access to Jetstream2 networks only, but we're on a Jetstream2 network. Yeah, we're getting a lot of people. Okay. Unfortunately, I don't have time to debug this. Yeah. No, I trust you guys followed me exactly. I have a feeling. Hmm. Let me just try one of these other instances.
Danny, I tried a random instance and it worked for me. But of course, I'm also on the IU network.
Yeah, I don't, but that shouldn't matter because it's doing it through the instance. I have a feeling what might be up. Someone's asking for the prompt I gave. Yes. Let me just try this. Oh, okay, this one works. Okay, if you're getting that error, try accessing another one of these AI-classroom, and then it's going to be like some number of some number. Just pick one at random if you are getting that error. I have a feeling what's going on is there might be an IP block that might be blocked. And if you're just, it's basically luck of the draw. So your IP on your instance is just randomized. but we have separate a few different IP logs, and they might be blocked at the IP level. And I'm wondering if there's a specific block that some of you have landed on and some of you haven't. Is there anybody that's not on, anybody here in the workshop that's not like an IU staff that's getting, this is working for? If it's working for you, let me know. I don't see anybody saying it works for them. Okay, well, I'm gonna have to explore that and figure out why. Unfortunately, I test this on here. Yeah, thank you. Yeah, just watch for now. I'm gonna explore this and try it out on my own network later and see if I can't figure out what's up, because this should work. There's no reason this shouldn't work. So yeah, if you're not able to get access, just keep watching. Sorry about that, everyone. The random instance works. Thank you. Awesome. It works on a different machine. Okay, weird. I don't know what's going on, guys. Thanks for being flexible and trying different ones. Okay, so I just want to summarize what was happening here. It's talked a little bit more about what it's doing. It says next steps with the plan, confirm the script and your test according to the steps below. Okay, implement a plan and test execution, debugging and solving errors as they appear until it succeeds. So I switched to the build mode, and I'm saying execute the plan and keep trying to run this. So we see already it found an error. It said no module named feed parser. So now it did pip3 install feed parser. So this is what I was talking about, this agentic loop, where it can do things, find an error, and then try it again. So it's saying, okay, we found an error. I know how to solve that error, and it fixed the error. It wrote AI news.py. Great. Make executable and run scripts. So it's running some shell commands here. So it's making these things executable. It couldn't fetch Reddit too many requests, so there's probably some sort of block on Reddit. Yeah. So it's trying to work around that. Test alternative Reddit feed. It's trying a different one. Okay, so it seems like it's really having trouble with Reddit. Let's see how I'll handle that. Somebody asked, how long will we have instances? We'll keep them around for at least a day. So go ahead, log in and try this and mess around with it as you like on your instance. I just ask that don't delete other people's instances. So yeah, just be thoughtful of your neighbors and your friends and colleagues. Don't delete their instances. We will delete things automatically after a couple days. Okay, great. It looks like this is running, and this is just going to take some time. It looks like it's trying to find a way around Reddit being troublesome and not and rate limiting us. Let's see what else it's done. It reworked it. It's done a lot. Okay, script is executable, blah, 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 and requires 2 Python dependencies installed earlier. Okay, so let me just ask it. Oh, here we go. Let's do this. I'm going to open a new terminal, a new tab, and let's try this. There we go. So it created this Python script and it gave us some instructions. So the way I got this is it says, here's some usage examples. So this first one I copied, show the 5 most recent headlines. And so I ran this, this script, and okay, it said it couldn't receive something from The Verge, but it found some other why adversarial AI training is. Maybe don't copy that file. I don't know. I don't know what any of this stuff is. It's just, we're doing this live, folks. But yeah, so this is how you can use an agent in your workflows. Super useful. I recommend, like, if you have a chance, show this off to your students. This is really, really much more powerful than just doing a chatbot interface. It can create files and show you how to execute files on your own system, and so on and so on. There's one more thing. I know. Oh, Jessica, we reached time. Do you need me to stop, or can I take 5 to 10 more minutes of time?
Take some more time. I think it'll just be up to the discretion of the audience if they have the availability.
Okay, yeah. Apologies, guys, if you all have to go. Totally understand. Hopefully, you've learned something. I'm going to show off one more thing, which is Jupyter AI, and then we'll call it quits and I'll wrap up. So I'm going to close out of all of this. On your instances, there should be another. I created a desktop icon, so this is just an example of I set up this environment. I created a snapshot of an environment, and then I launched a whole bunch of instances. So this is an example of something you could do for your class. So I actually created this desktop icon myself. If you were to launch an instance yourself, it wouldn't have this. This is like something I added. But when I launched all my new instances for you all, now it comes pre-built in. So I'm going to actually click on this. To show you what's possible, because I know there's a lot of Jupyter fans in the house. So as part of this, this is a pretty minimal Jupyter Lab setup, but it's installed Jupyter Lab, and it's also installed something called Jupyter AI. And what that comes with is this extra little icon here called Jupyter Chat. And if I click here, you can see there's no chats currently. It's a fresh instance. And I'm going to hit New Chat. And what we can actually do is open code is already set up to talk to the Jetstream2 inference service. And we can call open code through this. So I can say at open code, and now I can give it a prompt. So I can say create a Python notebook that demonstrates data science, or demonstrates a foundational data science principle and include documentation between code blocks that explain these concepts to a, let's see, freshman level audience. So let's try that. And you can see Jupyter AI, it's using OpenCode under the hood, which in turn is using the Jetstream2 inference service under the hood to act as an agent within Jupyter Lab to create things for me. And now it can have the entire context of my Jupyter Lab environment. And it can modify, it can create files, and it can execute these files too. It looks like it's still working. It says open code is typing. So it's adding all these cells. Okay, a complete Jupyter notebook illustrating a core data science concept, linear relationship correlation, and simple linear regression with clear freshman level explanations between code blocks. The notebook can be opened in Jupyter Lab and run side by side. Okay, let's see. Open code. Try to run this new notebook. If any errors are detected, fix them and rerun until the entire notebook runs successfully. I have a question. Can we delete the current instance and come back later today and start a new one, or the allocation will be over? I would say don't worry about deleting it. We're just going to leave them up. These are pretty small instances. So yeah, feel free to come back later today. I'll probably clean things up on either later tomorrow or early on Friday. So yeah, feel free to play later today and all day tomorrow. What LLM foundational model is running on Jetstream2? Yeah, thank you. So right now it's using I just by default I've been using GPT OSS what is it 120 billion. We do have other models available, and we're actually we currently we used to have DeepSeek. We're exploring replacement options for that because DeepSeek is a year and a half old now, so it's out of date. So we should have other models available now too. We also have Llama 4 Scout, I believe, and so on and so on. There are other models as well, and you can explore some of these as well. Yeah, and actually, when you open code, there's options for like switching between different models as well. Okay, Notebook now runs cleanly from start to finish. All required packages, NumPy, Pandas, and Matplotlib have been installed, and the code cells execute without errors, producing the intended data creation, visualization, correlation, calculation, linear regression output. So great. Now we have this notebook here that we didn't create at all ourselves. We just told the AI to create with a very simple prompt. So yeah, feel free to explore around with this and mess around with it. And I hope that you guys can bring this to your students and show them like, hey, here's the power of AI and beyond just a chatbot. Of course, teach them all about chatbots, teach them all about prompt engineering, but maybe you can show off some of this really cool, I think, stuff as well. I think this sort of stuff, in the next, as they proceed along, whether they're going to like grad school or if they're in grad school and they're going to like postdoc, or even if they're going to industry, like knowing some of this stuff and how to use this is going to be so groundbreaking and game changing for them. I mean, I wish I had something like Jupyter AI when I was a grad student. This would have saved me hours and hours and hours because really, as a grad student, I mean, I hate to say this, I don't care how the code works. I just need to produce a plot, right? I will learn it and I can ask it to learn it to me, but I don't need to understand, all the nitty-gritty of the actual Python language. I can understand the science and what it's doing, but like now I can create plots in Python without having to really understand the nitty-gritty of the language, the programming language itself. I can be a scientist, not just not a coder as well. Okay, I hope you have fun with that. I'm gonna conclude by just saying make sure to check out the slides if you're interested in getting your own allocation. We have a whole section on getting an allocation. So I recommend checking that out. And I'll conclude on a slide down here, which is connect with us. We have a mailing list. We have a community chat. You can email us with any questions you have, and we have office hours every Tuesday from 2 to 3 p.m. Eastern Standard Time, or Eastern Time, I mean. At that link there, you can also find this link on our documentation and on our website. Come talk to us. We love talking with you folks and helping you out. This is a passion of all of us on the support team, and we can't wait to hear from you. So yeah, thank you. Jessica, back to you.
Awesome. Thank you so much, Danny.